Thanks, Tracy, for the introduction, and hello everybody to this today's event of our webinar series. So the title of my short talk is Working as a Meta Scientist, Pitfalls and Merits from an ECR Perspective. So just to start, to give some information about my background, and I would say not only because everybody likes to see his own face on the slide, but maybe more that I think it's important to have some background knowledge why I take this perspective on meta science, because if you're coming from a different field or from a different perspective, you might view differently. So basically, don't to say this is the one and only perspective we hear today about meta science from an ECR perspective, but maybe more saying it's my personal story how I take up this topic. So my scientific background is that I did a Bachelor of Science in Psychology, also here in LMU, and then a Master of Human Factors and Engineering at the Technical University. So a little bit more somewhat of the exotic side, where basically I think it's also one of the plus points first started to getting a little bit more in this working in the interdisciplinary section. So in this Human Factors and Engineering, we had a lot of intersections with people from informatics. We have also persons from the engineering science and also the side of psychologists. So this was basically the first time since the bachelor leaving this really homogeneous level of all up psychology in my field and getting a little bit more in the more exotic fields of the engineering science. And right now I'm doing my PhD in the so-called MetaWeb program, which I will explain a little bit later what we are doing there and why this relates to meta science. And also to give you another part of, let's say, my academic career so far, which I think is important, I basically started since my bachelor's to be active in the field of open science. So different activities to promote the openness and the transparency of science. So I'm the coordinator of the Open Science Working Group of the German Psychology Student Representation. In Germany, it's called the PsyphaCo. And also active in the Open Science Commission of my academic society, so the German Psychology Association, and together with Tracy. So basically, that's also the field where we two know each other. We are members of the steering committee of the German Reproducibility Network. So these are basically the two sides which come together. And just to get everybody on board, I guess for all the people who attended this web series a little bit longer, this is not needed anymore, but just if we have a new person joining, give you a brief definition of what is actually meta science. So there is this famous one from Ioannidis, where he says meta research is the study of research itself, its methods, reporting, reproducibility, evaluation, and incentives. Given that science is the key driver of human progress, improving the efficiency of scientific investigation and yielding more credible and more useful research results can translate to major benefits. And as I guess you already know, so there are two main parts of this definition. So there's research about research itself, and then basically in all of its different, let's say, perspectives. So the methods, reporting, reproducibility, evaluation, and incentives. And what's the driver for it to make science A, more efficient, and B, more credible and more useful for also practical results. And I think this also relates, or this question relates very good to a term we will get later to, in which in psychology and also a little bit more broader in the social science, we call it the reproducibility crisis. So a lot of these meta-scientific, let's say, endeavors also emerge from this look at our scientific fields, where we say we have a problem with the replicability of our results, which I will come a little bit later on. So to give you some overview about the research cycle in psychology, which I guess is also generalizable for all fields, also like life science or biological medicine, who are dealing with empirical data. So normally we start with some kind of hypothesis. We draw from previous studies or from theory. We set up an analysis plan. We then have the field of data collection and, of course, the data analysis. In the end, we interpret and report our results, publish and distribute, so ideally open access. And in an ideal world, there also would be some kind of cycle where basically replication studies are conducted more frequently, so to check whether the previous drawn results are really valid in bigger or other samples, which right now is still a little bit lacking. So I think there's still this problem in the, let's say, the incentive structure, that the first original studies are a little bit more valued more on this merit scale than just doing a replication. But this redoing aspect is also definitely important and closely linked to this, what we refer as a reproducibility crisis. So, and then I want to tell you some ideas about my part where I emerged for this open science study. So basically in the end of my bachelor's and starting of my master's I did is a voluntary project in this open science working group. We did a survey on questionable research practices and open science among students. So it was a study with nearly 1,400 psychology students we fetched all over Germany. And we had the interest that we're asking ourselves how common were questionable research practices among psychology students. So to give you some idea whether you are already familiar with this term, so in questionable research practices is basically an umbrella term where we defined different problematic practices, like, for example, hacking, so that you, after you've seen your results and after you've done your analysis, so if you consider the research cycle I shown before, after you've seen your results, then you basically retrofit your hypothesis to the results you're now seeing. And at this point, basically throwing all this trustworthiness in this chain overboard, as you then can say, oh, this was what I was predicting in my theory, if you're going to the hypothesis after. Another one would be also that you have multiple conditions or multiple variables in your experimental setup. So for example, you have a gender, you have day, nighttime, or different criteria or characteristics of the experiment, and then you only report the variables or characteristics in the end which deliver a significant result. And of course, this also introduces some biases because you just leave out the other problematics. And we were interested, so there is also a lot of corpus of literature why these practices are, or to which prevalence these practices are acted upon within researchers, but we were interested, are they also present in students? And we choose in the end 9 questionable research practices and also 2 open research practices, which were in this case doing a power analysis before the study, so a sample planning, and pre-registering the study. So basically write all down, also parts like the hypothesis or the analysis down before you're doing the data collection. And at the second point, we asked whether the replication crisis, the topic of questionable research practices, and also open science are dealt with in the psychological courses. So basically, are they implemented in the academic teaching? And the third topic, or the third thing which we're interested in, were how well the students are informed about open science and how much are they interested in. So just to show you one slide of the results, because I think the story is more, let's say, one step in this whole story. It's not important that we go through all the details of this study. So here you can see the prevalence divided by research practices and also the empirical type of the project. Little sets of the only slides in German, so this graphics, but I think I can just translate it very quickly. So in the columns, you have different project types, which started on the left with the XBAR, which is an empirical project in the first semester. Then you have the bachelor or the master's thesis, which of course coming later during the course of the studies. And to the utmost right, you have other kinds of the miscellaneous kinds of projects. And in the rows, you have this aforementioned different types of questionable research practices, like for example, no prior sample planning. SB is always standing for selective reporting. So basically, you just report, as I said, the variables who worked out in the end in the analysis and not all. You have hacking, and which you can clearly see here is that there. So basically, the first result was that there is also prevalence of these problematic practice among students. And then I think a little bit more positive result is that the prevalence of these practices, so when the color getting more in the yellowish and away from the red, so they are going or growing less prevalent during the course of the study. So if we approach the master thesis, they are less prevalent. And of course, so this was an interesting project and basically one of my open science endeavors. And why I'm bringing this here to attention, because at this time where we conducted the study, so it was 2018, still some years ago, we were really viewing this as some kind of, there is some open science recommendation how we should make research more transparent and more reproducible. And we were interested how this topic relates to students. So this was our whole bubble, and we were fine with this. And this was also like in the end we wrote the paper, so really with this open science, let's say, best word as a selling point. And if I look at it now with the knowledge I also now gained through my PhD, it's basically a meta science perspective we're taking on in this project, because we were asking how these different topics, how these different practices basically relate to one subgroup who is active in academia, which of course are also the students. So, and I think it's not like you're getting a Nobel Prize for this incentive, but I found it really interesting that while we're conducting this study, it was really, so nobody has ever at this time known the term meta science, and still we were basically conducting this kind of research and taking on this perspective. And I think this is also, let's say, one bridge to get into meta science. So if you are active in somewhat, open science movement or are an advocate for open science practices, then every time when you are interested in how these practices basically develop and how they are coming on in the research community and how they are viewed and what is maybe also problematic in these practices, so then you are in some kind of, let's say, impact measure. So if you're conducting impact measurement of open science, then you are, and that's why these two circles collide in the middle, basically, when you then try to evaluate how this open science recommendations turn out in the end, then you're taking a meta-scientific standpoint. And now going a little bit back, in this second point, I talked so basically about the MetaRep project where I'm doing my PhD. So the MetaRep project itself is a research program for the analysis, optimization of replicability in the behavioral, social, and cognitive science. So you already see that these names, scientific fields. It's not only psychology; it's definitely a little bit more broader. And at least in my field, it was a really big, let's say, big news because it was the first time the DFG, so the German Research Foundation, founded a priority program which is specifically targeting to a meta-scientific question. So, and then also, let's say, getting this field more into the mainstream and not being that very exotic stuff, which some scientists do on their own. So basically really, acknowledge that is the need for meta science. And as I talked about it a little bit previous, so it was also explicitly stated by the DFG that this is a reaction about the low replicability rate in the social science, which is the term which is always named as the replication crisis. So if we're redoing the same experiment, ideally with a bigger sample size, so you have a higher statistical power, then you found a lot of, and I will show a graphic of this in a few moments, then you found a lot of effects of anomia in psychology which didn't replicate, or if they have a significant effect, it's much smaller than the original one in the previous study of the author who basically discovered this kind of phenomena or this kind of effect. And in this MetaRep program, so it's basically like all of these priority programs, some kind of umbrella project. There are different 15 individual projects at various universities in all of Germany. The project coordination itself is located at the LMU of Munich, and therefore we have also these, let's say, these broad perspective that in the MetaRep project we have sociologists, we have psychologists, we have also some persons from the philosophy of science perspective, also people from economics, so really a broad scale of researcher who are tackling these questions. And the MetaRep program itself, it's constructed around 3 research questions. So the first one is the what question, which basically means describe and define what the term replication actually means, and why we're talking about successful or failed replication in different, and also how this perspective change across different scientific disciplines. Then we have the why question, so basically why these replication rates vary between and also within different disciplines. And the last one, which then is also this, let's say, evaluation measurement of meta science. So there are different methods which were proposed in the literature, how to increase the replication rate and how this measure basically performs and what are the first insights you can draw on their implementation. So, and in general, the idea is to have a better understanding of effects and also their generalizability across different sample groups and countries. And just to name it, so why is this important to just give a practical example? If you have a new therapy form developed, and in the original study, they were clearly shown that in the treatment group, so the group who get this new type of therapy, the therapy works better than either giving no kind of treatment, so basically a placebo group, or let's say the standard treatment, which was conducted before. And then you only show this in one kind of sample, or basically in a Europe sample. And this effect is not replicability in another kind of cultural background, for example, or with a bigger sample size. Then you have basically a problem in selling that this is a valuable therapy who provides benefit for the patients. And now going a little bit deeper, so this is the project where I'm doing my my PhD twin. It's called the Drift project. And here, just to give you a picture of this aforementioned problem with the wreckability rate. So what you're seeing here to the left in the rows are different psychological effects, like, for example, anchoring, gain versus loss framing, sunk costs. I think anchoring is something which is quite familiar. So this is this effect when you describe in negotiations that the persons who first, for example, you want to try you want to sell a used car, and the first person who threw an anchor in this conversation and say, oh, this car, I guess I would pay 5,000 euro for it, and the following discussion will circle around this 5,000 euros and basically going relatively 1,000 euros up, 1,000 euros down, even if the car, for example, is only worth 500 euros in a good estimate. So this is described as this anchoring effect. And now looking to the graphic itself. So if you're looking at the axis in black, okay, so everything of the graphic is black, but just look for the axis. This is the original effect size from the authors. And we're talking about Cohen's d, so basically the difference between the control group and treatment group divided by the standard deviation. And 0 would mean there is no effect. And of course, going to the plus is a positive effect, and to the minus scale, a negative effect. And the x is the original effect size, and the different small circles are the effect size which were founded in different replication studies. And what is notable at this graphic is that these were all direct replications. So it was not that these researchers were basically assessing the same effect, but in a different experimental setting. So for example, they still want to learn something about anchoring, but they use they don't talk about a car, they try to sell a boat, for example, in a different setting. It was really exactly the same experiment like the original author, just with different sample groups and also cultural background. And you can see clearly here that the axis and the smaller bubbles are sometimes very far apart. So the big white circle is the averaged effect between all the individual studies. And as these studies were all conducted with a bigger sample size than the original studies, so they yield a higher statistical power, they are more credible and more trustworthy in this regard. And this is, of course, what we refer to the problem in wreckability, because there is this huge difference between the original studies and the perspective which might really is going on. So, and what we try to do in this Drift project is providing a valid assessment of heterogeneity in, as I said, only dealing with direct replication in psychological effects. So basically, with looking at heterogeneity, we ask why these small white bubbles, why they are not only all falling in this average, but they have also a standard deviation, or they're not the same. So what is the reason for this heterogeneity we can observe there? And this so-called between study heterogeneity is one of several possible explanations for failed replications, that there are basically systematic differences in this effect among the population from which replication samples were drawn. And then in the end, when there are, let's say, systematic differences, then it's we need to know this to talk about how the effect generalizes and also not generalizes. And I think it's psychology, it's still very, let's say, common to talk about. If we look at people, then it's, of course, if we measure latent constructs like personality, aggression, it's really in the sense that, of course, they're various. There's variation between, because not all people are the same. But if we then talk about effects, it's still this kind of mindset, yeah, my effect is, I don't know, Cohen's d of 0.5. So it's basically a point estimate. And we didn't have this idea in mind that maybe the effect itself, even if it's present, might be heterogeneous across different context variables. And therefore, the Drift project tackled the why and the how question of the MetaRep program. And now I think you got the structure right here at this point. Now going to this thing, what I'm doing basically in the end. So the goal of my thesis is exploring the effect of suboptimal statistical models on the estimate of heterogeneity. So basically, if you have one kind or one set of data, there are some kind of, let's say, decisions you can make, so also called research degrees of freedom, how you analyze this data. And I'm not really talking about questionable research practice, so that you analyze the let's say data in a fraudulent way, which of course, if it would be transparent, people would say, oh, no, you can't do this like way. It's more like there are different legitimate path you can go. So a little bit like referring to the last to the last webinar series where I had this talk by Cassie Short about the multiverse. So there are different plausible paths you can go, which also, of course, had influence on the results at the end. And I'm dealing with questionnaire data from these so-called multi-lab replication studies, where they all conducted the exact same replication. So this is called direct replication. And normally, I think it's also the same in your field when you're dealing with statistics. These survey data, I don't know, it's a Likert scale from 1 to 7. How so one question is, you have this trolley dilemma, for example, where you have a switch and the lorry car is driving on a track train, and you can decide whether you pull the switch so that one person would die because of the collision with the trolley car, or you don't pull the switch, so basically are passive and not interacting, and then the trolley car will crash into a family which is standing on the rail and 5 persons die. So this is like kind of some kind of these utilitarism philosophical moral dilemma. And there's one, so the dependent variable, the important one is in the end, how morally justified is it to pull the switch to in the end then kill one person to save 5. So this is one of the items I'm dealing with, and normally they are analyzed as continuous and not at ordered categorical. And there's a lot of literature in psychology that survey items are basically ordered categorical, which means if we're looking at the data, that of course someone who gives a statement, so clicks at 7 as the highest anchor, he or she is measured higher on this item than a person who clicks at the category 2. But there's no really, let's say, testing in it that the differences between 2 and 3 are equally to the difference between 3 and 4. And this would be one requirement to deal this data as continuous, so that there are equidistant distance between the different scalings. And it's just that we treat them as they had this property, but we're not checking it. And so a more, let's say, statistical fitting approach would be to deal with them in an ordered category way, but it's basically rarely or even never done. So with this in the background, I'm rerunning this already existent analysis of this multi-lab replication study with ordinal models to have this ordered categorical approach, as well as simulating data with different effect sizes. And then, and I think this is one of the last slides to the project itself, and then we're going a little bit more in a broader perspective. So what we think, what are the challenges and the merits also of the field of meta science. So last slide, the content of my thesis. So the statistical approach is at the first, we have a traditional meta-analysis, which is done in R with the package metaphor. And we have this ordinal model estimates, so basically conducting with the BRIMS package, which is a framework for Bayesian modeling. So, and these results from this first analytic approach are then compared to the meta-analysis results, which were already existing from the original authors, which were coming from this frequentist framework, where they treated the data as continuous. And then we can basically look at different heterogeneity estimators like I² or tau, and then make a comparison how the different model has an effect on this heterogeneity estimate. And there are also two other sub-statistical approach. So there's also, we also conduct a Bayesian multi-level model. And also there's the possibility in BRIMS to conduct a Bayesian meta-analysis, which is also a little bit different in the statistical details, which I think is not important right now. But so I think you get the idea that we try to tackling this heterogeneity with different statistical approaches, and then look what we can see in the estimates and whether these more ideal fitting models make a change or not. And also to give you some numbers, because at least for psychologists, these are high numbers. So we are always happy to deal with high sample sizes at this point. So it's the structure is always a two-group design, so control versus treatment. And a single item dependent variable, as I said, for example, is how morally justified is it to pull the switch. And we have, so this thing is an old number. So it as we started this project, we had 13 effects. Right now we integrated 4 new from recently published multi-lab replications. So I think right now we are at 17 from all over. So totally nearly 600 labs. So basically this were all the data collection sites where they conducted this stuff. And in total N of a little bit above 70,000 participants, which is of course for psychology backgrounds, that's a huge number. So we didn't need to worry about statistical power in this regard. So let's talk about coding. So just to make something which I think is not working in this group, because you're just seeing code and that's it, and the code itself is not important. But I also like to show this or similar picture in, let's say, the statistical teaching in the first text. So psychologists are not that let's say coding kings. So from the teaching, there are a lot of persons who try to study psychology, and they are not in this statistical mindset that they need to write a lot of code for the data analysis. And I think, as you can guess, when I talked about all these multi-replication projects, of course, you have the code for the own analysis. Then, as these experiments were conducted by different scientists, you also need to basically access their data, clean it in the way that I can handle it to tackle my question. So there's also a lot of data cleaning involved. And in the end, I think this generalizes that if you're working as a meta scientist, you need some kind of level of dealing with code and be able to program it myself. So of course, in the social science, I think the language of choice is basically R. A lot of the stuff we're doing is also totally fine if you do it in Python. So there are the same packages which consists in the R ecosystem also available for Python. So there's no really a quality difference. But I think this is something which is in this regard important, that if you want to be in the field of meta science or already active in it, then you need some kind of relation to writing your own code. And this is not something which, let's say, all psychologists are really familiar with or feeling fine with. Though I'm sometimes struggling. It's not that I'm the coding god at this point, but let's see, you need to have this mindset of just go in, look what it takes. In the case, just call ChatGPT for help. This is also fine as with the new possibilities it had right now. But you need to be familiar with this. And I think you still need to consider that at least not a negligible part of psychologists are still trained at softwares like SPSS. So from IBM, which is a statistical program which has a graphical user interface, and it's also, compared to art, very limited in the things it can do, or at least you then have to buy expensive DLC packages for this. And if your training as a psychology student or then a master student is based on this level of program, and then you're coming into the field of meta science, I think you have a hard time to enter. So in the end, some idea about, or some, let's say, my personal experience about benefits and challenges. So I think, which is great, but it's also can sometimes a little bit harsh, so that you need to be familiar with this idea of have a bird-eye view of your research question. So in my case, as I said, this is looking at these multi-replication projects and analyze them in the way that we have better understanding of heterogeneity, but we're not really engaging with the actual content of the studies. So of course, we're reading these studies, so it's a little bit like the joke in our lab. So yeah, we have found new data, and then, I don't know, we read the abstract and understand which variables are in, but going deep in the theory and why A relates to B, it's not that important, because in the end, we're more looking at this structure. So does this experiment fulfill this idea of having two groups treatment control? Does it have one item, which is the important variable to study for my approach? And what is basically the whole story of the researchers itself? It's this question goes in the background. Then I think, which is of course a great plus point, is the meta-scientific methods. You are learning like systematic literature review, conducting meta-analysis, web scraping, all this different stuff. You also heard about a lot of these in our web series, or also will still hear about them. Of course, as meta science goes mostly across fields, then you have also the strength to apply these methods in different areas. You have many opportunities for collaboration and networking with other researchers. So just throw in the highly praised term team science here. So as I already said, in our meta rep, basically sub-bubble, it's really nice to have also chat with philosophers who still tackling this what is a successful replication and why we replicate to strengthen basically scientific evidence, even from another perspective. I think this is very fruitful to have this conversation, but it's also sometimes demanding if every person is speaking basically from his or her perspective and from the terms he or she is familiar with. And then you need to basically, someone is telling a story, and then you need to ask, oh, what do you mean with this term? Please define this and that. So you also need this kind of, let's say, communication strength that yeah, person A is speaking about bananas and person B is only understanding apples. So you need to cross this bridge. Also, which comes benefit challenge depends on your viewpoint. You have no clear, I call it here in this space, discipline home base. Maybe there's also a better title out there, but no clear belonging in this sense. I think in my case, it's a little bit easier because I still can go to this, okay, we're doing methodological stuff. So we're coming from the statistics methods perspective in some way, but there are also other persons who, for example, they compare different paths in EEG measurements in this multiverse approach. And this is also distinct from the normal EEG study you were conducting, where not the different analysis paths play the major role. Instead, it's depending on what you want to learn with these EEG measurements. Yeah, and so one question I was also a little bit asking myself, so I still am a little bit doubtful. So how in the end, let's say our research results will also translate into the field. So I think there's still some kind of distance between also in your own area of psychology. So I don't know, in the end, if we're saying, oh, that's the state of art about heterogeneity, and these are some recommendations we can draw to them, how you should deal with your data and how should you choose your analysis parts, for example, will, let's say, the normal researchers, which his or her data we are using to conduct our analysis, will learn about this or will implement this in his or her own research. So there I'm a little bit doubtful whether this transition in the end will work out, but yeah, we will see. And then I think, which is also important, so so it's not on the slides, but just on the voice recording, which is also fine. So if you're looking on, let's say, career path, I think there we are not, let's say, still in a complicated situation, because if you're looking on, I don't know, postdoc applications or professorship level, there's nothing like, let's say, he's a professor for meta science, at least not as far as I'm aware of. So you still have this problem. Or just make it very bluntly, in my case, so I have now a 3-year contract by GFD, which is totally fine for my motion. But afterwards, if I'm going for a more permanent position, then I have this question: can I stay in meta science because there are permanent positions who allow me to conduct meta scientific research, or is it more that I need to go more on this general approach? Okay, I'm the stats methods guy, and I don't know, give me a methodological problem, I try to tackle it, and this is still, I think one of the challenges. Of course, as I said, and also laid out with the MetaRep program, there are starting initiatives to really fund these kind of research, but it's still very much away from the mainstream. And so I think that's still, so you need to keep in your mind that it might be possible, if you want to stay in academia, that you have some kind of switching to a different field and then try to still conduct meta science. But this is maybe one of the drawbacks that's, let's say, talking about the applications, this field is not that well defined. Yeah, and I think now we reach the end. So here still are the reference, which of course you can also look when we provide the slides. And now I'm really happy to receive your questions.